Und jetzt kommen wir zum absoluten Höhepunkt dieses Kongresses, dieser
And now we will come
Abschlussveranstaltung.
to the highlight of this conference, and this closing plenum, plenary. So I've already bridged the gap a little bit. So remember that I just talked about that time and again the Millennium Goals will become, Sustainable Development Goals will become more and more important. So I've just stolen cubes 13 and 14. 13 measures for climate protection and 14 life underwater. So that is the expertise of Professor Dr. Antje Boetius. In order to give you as much time as you need for your speech, I would like to only quickly introduce you. I would like to urge you to check out the website of the Alfred Wegener Institute located in Bremerhaven. I would also urge you to read on Wikipedia all of the things which Antje Boetius has already done, all the prizes she has won, so the German Environmental Prize a few years ago, German Environmental Award, the Leibniz Award, and now the Leibniz Ring, which also awarded her a prize. So she is one of the most outstanding researchers whom we have here in Germany, and I have to admit I wasn't really aware of that. I mean, I really say sorry for this, but today we've got her personally with us. Welcome, Prevention Speech 2019, Professor Antje Boetius. The floor is yours.
Ja, meine Damen und Herren,
ladies and gentlemen, it's a major honor for me after I received the invitation, and I firstly had to check what this Congress on Prevention is, the DPT. And I found out more and more about your work. I had a phone call with Mr. Marx, and I would like to say that I would bow to you for your work. So how can you even prevent things before they happen? How can you put all your efforts into improving this world and things? And with my speech on climate protection and the protection of unknown life and sensitive life, which it might feel as if it's totally far away from what you are doing if you work in a criminal police or whether you're a climate protector. But at the end of the day, both of us need to understand what's happening around, but at the same time we need clear guidelines for action. We need to formulate those and then convince our environment to just live up to those rules, even if it's difficult, even if it costs something. And so if you just have the stamina to listen to me for this next 30 minutes, then you will see that there are many communalities. So the topic is the discovery, how do we protect unknown life. So my research topic is the polar region and the deep sea. I'm a deep sea researcher, so I'm amongst those people who just have this lucky situation that we can just dive deep with submarines into the deep sea, so similar to people who have flown into outer space. And I really stand up to the sustainable development goals, but I also understand that they are quite complex. And if I take you now on this small journey, you will see that all of these things which feel far away, climate and also the underwater world, you might think, well, what does this have to do with me? What does this have to do with the next generation of people, of unborn life? You will see that these sustainable development goals are intertwined with all the others. So prevention. This is measures. I just checked this out in Wikipedia. So are measures to prevent situations which you don't want, which with a certain probability will happen if you don't do anything against them. And it preempts that there can be suitable measures in order to influence those events. And this is what we're talking about when we're talking about climate change and protection of seas and oceans. Why is this so important? So please try to understand the role of a deep sea researcher or an astronaut. If you think of Earth as an organism, the Earth as a water planet is unique. As far as we know, there is no second Earth. And even if some people are proposing that we should be looking for a new habitat in outer space because we're using up the old one, we researchers have to say, well, it doesn't look as if there is another option. We only have got this one Earth, and we should treat it well. Earth is 70% waters, an average 3.8 kilometers deep. So if you are lucky enough as me, if you can do research, you spend a lot of time in submarines, you meet alien beings, and you, as a biology, you also have to understand the chemistry and the physics of our planet. Everything's connected with everything, also the deep seas with us. Something with very few people know is that apart from being a blue planet, the Earth is also an ice planet. So since people have become farmers and have built settlements and then towns, so since civilization and industrialization has come about, since all of this time, we have been an ice planet. So the Arctic is an ocean up to over 5 kilometers deep with a thin sea ice layer and frozen areas. And then we've got the Antarctic, which is the southern part. So this is a continent huge, bigger than Australia. And that one is also extremely cold. It's the coldest point in the world because on that continent, on average, we have got 2 kilometers of frozen snow. Which is turned to water and then frozen. So these are glaciers, it's an ice mass. And all around this, you've also got a layer of sea ice. And then you've got the frozen ground, and also in the polar regions, the seas are below zero. So they don't freeze because they are salty. And also in the biggest areas of the seas, they are very cold. So most beings are adapted to temperatures between 2 and 4 degrees. Most species, not only in the oceans, but because most species who are unknown to us hide in the oceans, most species are adapted to cold temperatures. And now the finding that we humans, due to our changed behavior, are on the path and towards the so-called hot age. So sometime we called it a warm age, but now if we look at the extremes, we really have to call this a hot age. So this is a data set of the American Oceans Organization, Observation Organization, and you see the anomalies in degrees Celsius of an average as compared to the mean of the 20th century. So the blue was colder than the means and the red is warmer than the means. And if you know a little bit about statistics, and then you can see a clear trend. It's becoming warmer and warmer, and every year we break a new record as compared to the 10 years before. What does this mean, this becoming warmer? We are now with 0.9 degrees on average as compared to what we experienced as children or what our grandparents experienced. So why does it become so much warmer? And science has had this debate with society. Now, there are some strange beings who still say that the world would be a disk. Some say that it doesn't have anything to do with human beings, that it becomes warmer, but these are really strange beings. So we have got a clear finding. There is a correlative statistic. So what you are seeing here is what climate change deniers have been using for so long. We said, why is the warming of the Earth human-made? It has always been warm and cold. But so if the Earth changes its angle to the sun, and if you move 400,000 years back, so if you think of the frozen Antarctic with a 2 kilometers ice package, if you take a core out of that and look as the tiny air bubbles, then you can travel back in our atmospheric ages and determine the CO2 content. And in blue you see the fluctuation of the CO2 content in the world at different hot and cold times, and in red you see the proxies from other Earth systems, so from other indicators, which can be derived from that from 100,000 to 400,000 years from now. And if you now, as a criminalist, try to find out what's the driver here, So what do temperature and CO2 have together with each other? So you see that they have got similar curves, but if you look at it very closely, you see first temperature and then CO2. So, and this is enormously important for the statement which we are making today, that we can't afford to move beyond the tipping points in the Earth system, because if the Earth becomes so much more warmer, then it will emit so much CO2, because part of the carbon which is contained in the atmosphere sinks into plants and seas and so on. And if it becomes warmer, then the ground, the plants, the sea will release CO2 into atmosphere. This is when the tipping points happens. So what does this mean for us? So when we look at the data, we'll see that very soon we can look at the ice cores up to 1 million years ago, so we can see what happened at the beginning of the history of humanity with CO2. So what we learn from Earth is totally relevant for us in order to understand what will happen if we even make Earth even warmer than it is now. So in our history of the Earth, we had between 100 and 200 ppm and in fluctuations, and now we are at over 400 ppm CO2 in the atmosphere. Now, if we take our knowledge and if we just ignore all the other things, the volcanoes and the angle to the sun, then we see this as a correlation between time and increase in temperature. So we just took out all of the things which the Earth normally does. So the Earth angle, sun patches, we took all of that out, and we only see that it's only about greenhouse gases in the air. So what does this do with us? Here we see the temperature fluctuation only in Germany. We say, well, there's no climate change yet. We have got so much time for prevention. But this is the average in Germany, and we are quite far, considerably far away from the average, and we are insecure of how things will develop. So if we continue on the path where we are on, was demonstrated to us by last summer. So as comparison, in June, before we had this long dry period, this is the area, this is the land, and then afterwards, this is Denmark, where in Denmark usually it's wet in June and July. Now, I would like to focus on my research area, the polar region. So the question is, what do we need to do in order to avoid something which we can a disaster as being scientists, because the path we are on will lead to catastrophic reaction of the Earth system. And if we will have another 1 or 2 degrees, then we will have additional CO2 from the seas, because the seas and others will release the CO2. And now, in this communication which we climate researchers are using, that the task to avoid all of these, bringing people on board, and we are using similar language as you are using. It's about prevention. And so there was an interview with the Red Cross about natural catastrophes. Many of those have got to do with climate change. So all the funding which we can put into adapting infrastructure in order into saving people is a good thing. So the Office for Nature Protection say health prevention and nature prevention go hand in hand. We've learned in the German news program and that scientists from all sectors say we now need to change infrastructure, because this will save so much money for the next generation. We need to take decisions now. But what about the polar region? What's happening there? The polar regions are the early warning system for what's coming. And the polar region, especially in the Arctic, and global climate change has already arrived. Why is that so? They're in the north, they're cold, they are white, and wherever the ice is melting, where it can't reflect the sunlight back, it absorbs the heat so quicker, and the life of the species changes so quickly that they can't adapt anymore. So this also affects the life of the algae and whales and the whole board. So being aware of the early warning systems, and where so we people are we are used to our Earth, but everything's changing. Glaciers are melting, permafrost is thawing, and releases so much more carbon, but also sludge into the seas than ever before. And this have to be early warning systems. So in my lifetime, and here you see the timeline 1980 until today, I, as an Arctic researcher, have seen how sea ice vanished in the Arctic. So this is about the space of the sea ice in the Arctic Ocean, and this shows a trend. And so it's retreating, and I was the head of the Polar Star, Polarstern exhibition. What did I see there? As a student, I was in the Arctic, and the ice was 3 to 4 meters thick. So when we went through there with a ship, it was really difficult to get through there. And we tried to get to a region in front of Siberia in order to carry out our measurements, and was hardly possible to get there. And in 2012, I went to the same place again, and I saw something which signalized to me again. And since then, I've changed my research and my communication. We have to look at this more closely. We have to use everything which we can as human beings in order to understand what's happening here. So what you are seeing here is the sea ice layer in 2002 on the North Pole. And here we just, 2012, and we just drive through it as if it was butter. So because it has melted to less than 1 month in summer, and these black holes which we see, and we just, when we as researchers do our our core, if we take it out, and then it's so easy to get the ice through, because it's so much warmer. We human beings need to understand those non-linear processes. So if we just change little bits, we will change so much more than we could ever have predicted before.
The spread of ice that we had over the history of mankind in the north is shrinking. And what does this do with global heating? Even if you didn't like physics in school, you will understand it, that white areas reflect sunlight back. And if we have more and more black and dark ocean underneath, it will absorb the heat of the sun and will melt the ice from underneath. And if you have wind pushing sea ice back and forth, it will melt even faster. And then we will lose our capacity that our planet has to reflect back the heat, and our climate will heat up. And that's what our future looks like, which is why we no longer talk about warming times. We talk about hot times, and everybody says this is doom and gloom, and the scientists need research money, and so they're exaggerating. But you know what it's like if you have statistics, if you have trends, if you say, if we continue with business as usual, what will happen next? Then you're just telling the truth according to your conscience. So what are we seeing here? In our region, in the north, but also in Northern Europe, we are seeing the increase of global heating faster and faster. I'm already talking 2 or 3 degrees than we were in the mean. The north is already experiencing what we are going to have at the end of this century here. And at the moment, for the first time in the history of man, we now have more than not just minimal ice at the North Pole, but also at the South Pole. And this is because of what's happening in our climate. And we're standing in front of the coasts of the Arctic, and this is what we see. You see people looking at the Arctic coast, and all around the Arctic Ocean, everything is frozen, and they're great big packages of ice with methane frozen in there, carbon frozen in there, and plants from previous generation. All of this is thawing out and sinking into the ocean. One of the things that we've learned is that when the ocean gets hotter, it emits even more carbon into our environment, and we must prevent this, because if we don't, everything will happen even faster than it already is. And what does this have to do with us? Well, we're only learning now through improved climate models that the stability between the polar vortex, a wind band going around the North Pole, that we're seeing, you've heard of the jet stream, I'm sure, But here, the polar vortex is a stable system. It rotates quickly, keeps our weather stable. You're seeing it slowing down. The polar vortex is getting slower and less intense, and that is changing the flow of the jet stream. And what does this mean? This means like last summer, we have incredible heat and drought. And in the North Pole, what we've seen is that sometimes things in the middle of winter, when the polar bear is hibernating, we don't know if they're going to wake up if it gets warm. It's getting warm in the middle of winter. And we're also seeing the east from the beast. Cold air fronts coming from the North Pole, where it can be minus 20, minus 30, minus 40 degrees. And if the jet stream wobbles like this, then it'll send all of this cold air to places like Chicago, as happened last year. These are all scenarios that will change our weather in extreme situations, but that's not all. It's not just about us as human beings, it's about the nature that we know. It's about the creatures that live on this planet that belong to the earth and belong to us. The walrus, for example, that raises its young on an iceberg. It needs access to food sources. But if the sea ice is changing, then the mother walrus can no longer swim to it with its babies, and it will not survive. Divers show us what it looks like underneath the ice, and under all of this diversity of life that we're only just discovering, that we don't even know yet. Then we know through this fast warming that is ahead of us that before we can even document these species, they will disappear off the face of the earth. Does that mean something to us? This is a connection that we're disputing a lot. You will have heard that the World Biodiversity Council has just published that on the planet, every 8th species is threatened by extinction. And again, they say, are these scientists mad with their hysterical statements? But there are thousands of findings that have been compiled by hundreds of experts. It's just the truth. What does this mean for what we need to do? And this is natural science that I'm going to try to explain to you simply. I don't think anyone will find it hard to understand that if the sea ice level used to be here and the walruses were used to just having to go 50 miles over to land, and if the ocean warms up and the babies are born here with their walrus mother and they're all the way over here, how are they ever going to swim to land? They're not going to make it. Surely you can understand that if I'm telling you that. And these kinds of connections we did not predict. We didn't undertake prevention measures in time to prevent it happening. Now, let us go under the sea. Once again, apart from polar research, that's the other highlight of my professional work, that I can sit in a submarine and disappear from our busy world. Then I go through the light-flooded surface of the sea and go 200 or 300 meters below sea level, and it becomes dark as anything. We cannot live here. I couldn't get out of the submarine, and you can see all of these strange deep sea creatures that we are only now exploring. They send light signals to one another and sounds to one another, and these fantastic creatures are rare because in the deep sea there's almost nothing to eat for them. It's so dark that there are no algae, no plants. They live from matter sinking down to them from the surface. And by carrying out a census of the seas, all deep sea researchers carried out a census of marine life. There were 10 million different species of marine creatures, some looking as bizarre as these. Look at this. Everyone loves this. It's a little Dumbo. It's a fish. This is a crab. These are creatures who are so rare and so unusual, and most of them live with certain bacteria in a kind of coexistence, a symbiosis, depending on other species. We are still only just discovering them and studying them, and now we know that the deep sea, where no one lives, no one goes on holiday, that the deep sea is changing just as intensely as the surface of the seas. And why? What happens at the top? The sea ice shrinking. Obviously, you understand what happens with polar bears and walruses, but the deep sea lives on things that sink down. And these creatures here eat mud. There are no plants there. They eat the things that have sunk down from the sea's surface. And there are all manner of different species that live on this. And what we're doing as human beings is that we're changing the surface, which means we're changing their food chain. And this is why we have shown in the last 10 years, observing the marine life in the deep sea, particularly the Arctic, that in this unknown area, some people call it uncharted territory, the unknown planet on the planet Earth is changing just as the rest is. And finally, and this is a bitter finding, because the way we deal with plastics has spread all over the planet. Why is it in the deep sea, in the Arctic, there's hardly any tourism? No one's there because plastic rubbing off from everything we do, from the way we build our carpets, our clothing, disposable plastic bottles, all of this is spread to the deep sea in snow. Tiny microparticles of plastic sink to the bottom, and we have a level of plastic in the Arctic's ice and snow that it's even more there than it is on the coastal areas. No one would have believed it, but it's true. The observation and the conclusions that we have to draw here are, it's sometimes like detectives trying to work out who the criminal is. Why is this there? How did it get there? And then we have to confront you with images like these, because the result of our human activity is that we didn't think about what we were doing. If we create lots of disposable material in a material that cannot decompose in the ocean because no bacteria can decompose it, and it's so dark that even the sun won't help, then this plastic is here to stay, and it impacts on all the creatures who live in the sea. I had a net that I cast out into the deep sea and carried it 50 meters. There were plastic bags there even when I was a student, but nobody thought about the fact that at some point there's going to be so much plastic that it will literally endanger species. And in one generation, this is happening. Will we get this under control? That's the major question here. What can research do? We have to continue to look. Part of your job is bringing together all of the knowledge out there and decide what will be likely coming in the future and where do we have any leverage? Where can we change anything? Part of this is researching internationally on things that haven't been researched yet. This September, we are setting out from the biggest polar expedition of all time on the North Pole with the Polar Star, and it will be frozen into the ice for 1 year, like the last major expedition that we saw here from Friedrich Mainz. And the polar night, when there's no light at all, we're going to be researching how the sea ice and the air are impacting on life. No one has done it with our modern methods. We know so little about our own planet sometimes. The activities of human beings continue in the impact of what they have done. Friedrich Nansen said this, and it's still true. We always have to look at the impact of our activities, of what we do. And these are the last thoughts that I want to share with you. What can we do as human beings above and beyond research and observation and compiling the facts and presenting them to people and warning that we cannot continue with business as usual? Why can't we? Well, it's simple as when I explained to you the connection between sunlight and sea ice. Here you can see not just carbon measurements in our atmosphere, but inferring where carbon comes from into our atmosphere. This is the worldwide consumption of fossil fuels since 1900. This is where industrialization started. In its inception, the emission of coal and oil was less than carbon emitted by agriculture. Agriculture played a huge role in carbon emission, but since 1980, our human behavior has accelerated climate crisis through the use of coal, oil, and gas. And the measurements are clear. This is what we're consuming worldwide. In agriculture, we haven't really managed to change it completely, but at least in terms of its carbon emissions, it is not growing as quickly as fossil fuels is. Here you can see oceans, the absorption of too much carbon emitted by human beings by the ocean. You can see 1/3 of what we emit is absorbed, and this leads to acidification of the ocean and the destruction of the coral reefs. And in terms of how much carbon land can absorb, this is mainly plant sinks that absorb carbon, and they can basically consume this. But then you have to ask yourself, what happens with the trees, with the grass, and the steppes that are carbon sinks if our temperature is increasing? Well, you have more forest fires, as we're seeing. What about if we, as human beings, are deforesting the rainforests that are carbon sinks too? Then we'll see the amount going into the atmosphere. This is only going to increase, and this is why it's so important that we think about preventing what is otherwise going to happen. And it's not just thinking about it, we have to act. You can see here the pathway we are on in black. These are our carbon emissions. If we assume that humanity will continue to grow at the rate that it is growing now, and if we assume that everyone will consume as much carbon as we are consuming, then soon we will be here. We will be in a world where until the end of the century, we will have more than 5 degrees heating of the Earth. And this is called alarmism in the media, but it's just crunching the numbers, looking at the growth of human being and the call for cheaper clothing, flying, and all the rest of it, meat, all the things we think we can't do without in our modern world. And here you can see these more friendly scenarios. This sets out the climate goals that the international community has agreed to, the +2 degrees. And what do you discover if you see this? You see that a miracle would have to happen. In 2020, the whole world has to be smart, have understood physics, stop emitting carbon into the atmosphere, stop with coal and gas and oil, and get rid of more of the carbon that is in the air. So is that a realistic scenario? Is there any hope? What is prevention? We have to be honest with all citizens, as you do. You talk about what happens if you don't carry out preventative measures. And we have to do that too. We have to say something must be done, because these costs and passing the buck to coming generations, conflicts and migration in Pakistan and India and in Australia already, for several days we have over 50 degrees Celsius. The birds fall from the trees, and human beings cannot stand temperatures like this without becoming aggressive and hysterical. There's also human behavior, because we are not made for these temperatures. But how are we going to manage it? It's not enough to say Germany doesn't have to do anything. It doesn't help to say, well, the Chinese are to blame for everything. That's not true. It's our consumption of products which causes the Chinese to emit so much carbon. What we, as climate researchers and marine researchers, all we can do is tell you the truth and say, look, human beings, we have very little time. And then we have to be very different people. Otherwise, we are going to have a big, big problem, an emergency. Only if we achieve this wonderful scenario, and if by 2020 we stop using coal worldwide, only then will we be able to keep the sea ice that we have in the summer, and then the polar bears and the walruses. And if we don't, once every 10 years, we will lose even more. It will be the end of these Arctic species that only exist in the Arctic. And this is why more and more scientists are saying the young people who are going on the streets are right. We are stealing their future. The future that we are enjoying now in the present day, they will not have. Ladies and gentlemen, this is perhaps not a happy note to end on, but I'm sure you are used to even harder things than I am, because you are used to using data and findings to think about violence and horrible things. And you know that, as we've heard, we need to make our society one that has a resilient democracy. But I hope that you have understood what I have said to you today, even though the Arctic's far away and the polar bears are far away. But what's coming will change everything, also around migration. This is why we have to join forces and hope that somehow we manage to make this stop. Thank you.
Vielen lieben Dank.
Thank you very much.
Ganz herzlichen Dank, Frau
Thank you
Boetius, für
very
diesen
much,
Vortrag.
Ms. Boetius. I've lost my voice. I don't know what to say. Thank you very much for talking to us the way you did. And let me tell you that you can download this speech on the internet. Take it with you to the next parents' evening, to the next party that you have with your family or your friends, and spread the word, because it makes it clear once again just how important it is that we get down to action. We have to really get prevention going. It's much more essential that we talk about these things, not so much about truancy. We have to listen to young people who have the Fridays for Future movement. And if we have parents for future and scientists for future, we still need prevention for future too. So let us try and do this together. And on that note, I want to thank my wonderful team for a wonderful German Prevention Congress. Thank you for coming. Thank you for all the active speakers. And thank you so much, Ms. Boetius, for your talk. And we'll stick to it. We'll manage it somehow. All the best and goodbye.